Okay, so we are looking at Chemistry Live. We are looking at 1313, which is one of the ethanoic acid and sodium hydroxide titrations. We figure out what we need for our table. So attic and basement, we want a volume, we want a big M, and we want an N. So the ratio, moles in the ratio. We know for the basement that when we're looking for this, it is going to be a whole number, something that can be measured out with a pipette. So if we read across, we have this piece of information. So we now know that we're putting 25 centimeters cubed of base. So this is the NaOH. And we know it's 0.11 big M, and we know its ratio is 1 from our equation. We are then reading through to find the other titer value. So when we do that, we find it's 15.8 centimeters cubed. We know that the ratio is 1 for our ethanoic acid. And if we read down, it says we need to calculate the concentration of ethanoic acid. So this is definitely our question mark. We need to look at our extra info. And in the extra info, we have 20 centimeters cubed was diluted to 1,000 or 100 centimeters cubed. So we divide 100 by 20, and it is going to give us a dilution factor of 5. So we're going to need that at the very end. So we are going to do our W, where we start off with our big M value in 1,000 centimeters cubed for our way in. We divide it by 1,000 to find out what's going to be in 1 centimeter cubed. We then go up by multiplying by our titer volume. We will then have moles at the end point, so we're going to use our ratio. We then again divide by our other titer volume to find out how many moles in 1 centimeter cubed of this. And finally, we multiply by 1,000 to give us our big M value, moles in 1,000 centimeters cubed. We will also at some point have to use our mass triangle. So moles, mass, and a molar mass, which we'll calculate from mass numbers. And we will have to convert into percent weight per volume at some point. So we're going to get on with our maths. We've said this here is our way in. And as always, we just say what this means. So this is 0.11 moles in 1,000 centimeters cubed. So we're up here at this point of our W. The next thing that we do is we divide 0.11 by 1,000. So when we do that, it is going to give me 1.1 by 10 to the minus 4 moles in a centimeter cubed. Brings me to here. We now go up to find out what's in our titer volume, so we multiply it by 25. When we do this, we get 2.75 by 10 to the minus 3 moles in 25 centimeters cubed, and that is one of our titer volumes. Brings us to here. We now use our ratio. The ratio is 1:1. So that implies I must have 2.75 by 10 to the minus 3 moles, except now this is in my other titer volume. So 15.8 centimeters cubed titer volume. We've just gone across the flat bit. And I need to work out what's in 1 centimeter cubed. So 2.75 by 10 to the minus 3. And I'm going to divide that by 15.8. And I now end up with 1.74 by 10 to the minus 4 moles in a centimeter cubed. So we're just here. And to finish off my maths, I am going to multiply it by 1,000. So when I do that, I get 0.17405. If I leave it like this, I'm going to have a slip because I don't have the right number of correct significant figures. If I have a look at my table up here, this 15.8 is 3 significant figures. So I am going to be interested in the 3 significant figures, which brings me to 0.174. The 0 is not going to make it round up. So 0.174 big M. You've always said then you do your moles by your molar mass, which is going to be 0.174, and it's going to be my molar mass of my ethanoic acid. We always show our working out, so we can't lose marks because of wrong final answer. So again, if I make a mistake here and I write 61, but I have all my numbers right, they would count this as a slip as opposed to completely wrong. So I will make sure that my maths is right. This is going to be multiplied by 60. And when I have done that, it is 10.4. There's 430, but I'm going to go at 10.4 grams in a litre. Now, because this is ethanoic acid titration, this concentration is our diluted vinegar, as is this concentration is our diluted vinegar. Okay, and remember from our data table, we always use every number that's in there. So we have a look at our question up here, and it is asking us to calculate the concentration of ethanoic acid in the original vinegar in moles per litre, grams per litre, and percent weight per volume. So our dilution factor we worked out was 5. So to turn this diluted volume into original vinegar concentration, I multiply 0.174 by 5. When I do that, I end up with 0.87 big M, and this is my original vinegar concentration. So this is going to be the answer to part 1. To turn my grams per litre, I also multiplied this by 5. So 10.4 by 5 is going to give me, is equal to 52 grams in a litre, and that is my original vinegar. So this then is also going to get boxed, and this is point number 2. And again, if you can't annotate, that's fine, you just make sure everything is done correctly. And the last thing I have to do is turn 52 grams in a litre into a percent weight per volume. So percent weight per volume, if I had €1 for everyone that gets it wrong, I'd be so rich. It's grams in 100 centimetres cubed. So I take my 52, I divide it by 1,000 to find out what's in 1 centimetre cubed, and I multiply it by 100. And when I have done that, it's going to be 5.20 grams in 100 centimetres cubed. And I just rewrite that as 5.20% weight per volume. Box it, annotate it number 3, and I am done.